Section 10.2.1, we're going to learn about tree diagrams. A tree diagram is a useful method for organizing information, counting outcomes, and finding probability. In this example, we will use a tree diagram. It says a national advertisement says that every puffed barley cereal box contains a toy, and that the toys are distributed equally. Talia wants to collect a complete set of the different toys from cereal boxes. If there are two different toys, what is the probability that she will find both of them in her first two boxes? Okay, so we're going to use a tree diagram to set up what's going on here, to find out how many different outcomes there can be, and then ultimately find the probability of getting both toys in the first two cereal boxes. All right, so when we read this problem, we have to sort of break down the situation and understand what Talia is doing. She's trying to get both toys in her first two cereal boxes. So in a sense, she's getting a cereal box, she's taking the toy out, right? And the toy that comes out of that first cereal box, it could be the first, or it could be the second toy, either one. Once she has that first cereal box and the toy from it, she's going to get a second cereal box. And she's going to take the toy out of that cereal box. And it's going to either be the first toy or the second toy. So we need to set this up as a tree diagram. So the first thing we're going to do is going to represent the first cereal box. And in that first cereal box, she could get the first toy, or she could get the second toy. Now that she has gotten her first box of cereal and the toy from it, she's going to get a second box of cereal. And she could get the first toy or the second toy. Now we need to represent this second scenario off of both possible outcomes from the first scenario. So up here, we're going to say, well, in the second box of cereal, she could get toy 1 again, or she could get toy 2. But on that first box of cereal, if she got toy 2 from it, then we have to work down here. Now in the second box of cereal, she could get toy 1, or she could get toy 2. So now this tree diagram shows us all the possible outcomes of the situation. Now we can actually answer the question. Find the probability that Talia gets both toys in her first two boxes of cereal. Well, we have 4 different outcomes here. The first outcome is she gets toy 1 in the first box of cereal and toy 1 again in the second box of cereal. That's obviously not going to work for her, right? The second possible outcome is that she gets toy 1 in the first box of cereal and toy 2 in the second box of cereal. That's going to work for her. She's now gotten both toys in the first 2 boxes of cereal. The third possible outcome is that she gets toy 2 in the first box of cereal and toy 1 in the second box of cereal. That's going to work for her too. The fourth possible outcome is that she gets toy 2 in the first box of cereal and toy 2 again in the second box of cereal. That's not going to work for her. So we've identified that outcome 2 and 3 will give her what she wants. That's 2 out of 4. So the probability that she gets both toys in the first 2 boxes of cereal is 2 out of 4, or 1/2. Same problem. Talia, cereal boxes, toys. But now, if there are 3 different toys, what is the probability that she will have them all after buying her first 3 boxes of cereal? So this tree diagram is going to be bigger, more complicated. because now we have 3 boxes of cereal and 3 toys. Right? We know that the first thing that's going to happen is Talia's going to get the first box of cereal, and that there are 3 possible outcomes. She could get toy 1, or she could get toy 2, or she could get toy 3. Now you're going to see as we create this tree diagram, things can get really messy in terms of the drawing. You might have to erase and redraw the tree diagram. Okay? This takes some time and some effort. Next, Talia is going to get the second box of cereal. And of course, in the second box of cereal, she could get any of the 3 toys. Well, we have to draw that for all 3 outcomes that we already have in our tree diagram. So up here, we're going to say maybe she gets toy 1, or she gets toy 2, or she gets toy 3. And then we have to do the same thing down here. So I'm going to extend this to just make my tree diagram a little bit cleaner. She could get toy 1, toy 2, or toy 3. And then down here, she could get toy 1, toy 2, or toy 3. So we've taken care of the first 2 boxes of cereal. So now Talia gets her third box of cereal. And of course, again, she could get any of the 3 toys. So we have to represent that off of every branch that we have so far. 1, toy 1, 2, toy 2, 3, toy 3. Toy 1, toy 2, 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 toy 3. And toy 1, toy 2, and toy 3. Okay, so we have all the different possible outcomes here. And we can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27 different outcomes. And we need to see which of, or how many of these outcomes result in Talia getting all 3 toys. Right, so let's go through. Start with our first box of cereal. If she gets toy 1, then toy 2, then toy 3, that will give her all 3 toys. So let's circle that because it works. Or if she gets toy 1 first, then she gets toy 3 first, then she gets toy 2 last, that will get her all 3 as well. Obviously, she can't go toy 1 and then toy 1. That won't get her all 3. So now let's go to toy 2 in the first cereal box. So she gets toy 2, and then she gets toy 1, and then she gets toy 3. That'll get her all 3. Toy 2, toy 3, toy 1. That'll get her all 3 as well. Obviously, she can't get toy 2 and then toy 2 again. Finally, in the first box of cereal, if she gets toy 3, and then toy 1, and then toy 2, that gets her all 3. Or if she gets toy 3, and then toy 2, and then toy 1, that'll get her all 3 as well. So we have identified 6 different outcomes that get Talia all 3 toys in her first 3 boxes of cereal, out of a total of 27 possible outcomes. So the probability that she gets all 3 toys in the first 3 boxes of cereal is 6 out of 27, and we can reduce that because 3 goes into 6 twice, and 3 goes into 27 9 times. So the probability is 2/9. All right, in our last example, things are going to be a little bit different. Let's see how. Mr. Rohrich teaches 3 classes. Each class has 20 students. His first class has 12 sophomores. His second class has 8 sophomores, and his third class has 10 sophomores. If he randomly chooses one student from each class to participate in a competition, what is the probability that he will select 3 sophomores? So we've spent a couple minutes here analyzing this problem. We've decided that Mr. Rohrich is making 3 choices, so there are going to be 3 levels of branches, and each time he makes a choice, he's either choosing a sophomore or not a sophomore. So now we're ready to start drawing our tree diagram. So his first choice in his first class, he's either going to choose a sophomore or not a sophomore. We want to label each branch with a probability. So what is the probability that Mr. Rohrich chooses a sophomore in his first class? 12 out of 20, which is what as a decimal? 0.6. If the probability of choosing a sophomore is 0.6, what's the probability that he doesn't choose a sophomore? 0.4. We've taken care of his first choice, right? Now let's go to his second choice in his second class. We know again he's either going to choose a sophomore or not a sophomore. So we have sophomore, S, not a sophomore, MS. We have sophomore, S, we have not a sophomore, NS. What is the probability that Mr. Rohrich chooses a sophomore in the second class? So the probability of choosing a sophomore is 0.4. That means the probability of not choosing a sophomore is 0.6. 0.4, 0.6. We've taken care of his second choice. Now let's go to his third class. And again, he's going to either choose a sophomore or not a sophomore. 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 And what is the probability that he would choose a sophomore in this class? 10 out of 20, or 50%, or 0.5. So then the probability of not choosing a sophomore is also 0.5. The question is, what is the probability that he will select 3 sophomores? Well, let's find the path, or paths, where he would select 3 sophomores. Obviously, he would select a sophomore in the first class, right here. He would then have to select a sophomore in the second class, right here. And he'd have to select a sophomore in the third class, right here. In fact, this is the only path that gives us 3 sophomores. So to find the probability that Mr. Rohrich would select 3 sophomores, we're going to take the 3 probabilities and multiply them together. So we're going to take the 0.6 right here times the 0.4 times the 0.5. We get the probability of 0.12. Okay, this example was different than the previous two because we multiplied the probability of each branch to come up with the probability of getting the three sophomores. This is what we call the multiplication rule, okay? And before we talk about the multiplication rule here, we need to identify independent events. Two events are independent events if the occurrence of one has no impact on the probability of the other. In the examples that we've done today, we were dealing with independent events. Think about the cereal boxes. Talia gets a cereal box. She opens it, she gets a toy. That has no impact whatsoever on what toy the second cereal box is going to contain. They're completely independent of one another. Then think about Mr. Rourke. Whatever student he chooses in his first class, whether it be a sophomore or not, has no impact on whether he chooses a sophomore or not in his second class or his third class. They're completely independent of each other. These are examples of independent events. When you have independent events, we multiply the probability of each event happening to get the probability of the total outcome. That's what we did in the last example, and we actually could have done that in the previous examples. Let me go back and show you how. We're back here to our very first example, right? And what we did here is we found that 2 out of the 4 outcomes gave Talia both toys in her first 2 cereal boxes. Well, we also could have used the probabilities here. The probability of getting toy 1 was 0.5. The probability of getting toy 2 was 0.5. So all of these are 0.5. Now we identified paths 2 and 3 as giving Talia both toys in the first 2 cereal boxes. Well, path 2 would go like this. Toy 1, toy 2. 0.5 times 0.5 would have given us 0.25. The second path, or actually the third path that we numbered, toy 2, then toy 1. That would have been 0.5 times 0.5, which would have also been 0.25. But then since there were 2 paths, we would add these together. 0.25 plus 0.25 is 0.5, just like we got here. So what I'm telling you is you can take the total number of outcomes, or the number of outcomes that work over the total, like 2 out of 4 gives us 1/2, or you can multiply the probabilities of the individual branches, and if there are multiple paths that work, you add them together in the end.